Okay, for this video, we're going to review the power rules. So let's do a recap. We have the product rule. So what our goal is if we have two bases that are the same and we're multiplying, we can write this as one factor. And the way we do that is we combine the exponents by adding. So for example, we have b to the fourth times b to the negative 1. We can really just write that as a single b factor, and we add the exponents and we get positive 3. When we have an expression where we are dividing bases that are the same, again, we can condense this. Instead of having two x variables, we can write it as a single variable by subtracting the top exponent minus the bottom. So for example, I'm just going to write my base of w. I have a single w now instead of two w's, and I have the rule which says 3 minus 7, and this gives us, if you like to do keep, change, it gives us negative 4. Now we can't leave w to the negative 4, so our negative rule said that we need to make it into a fraction, and when we put the w to the negative 4 into the denominator, that takes off the negative on the exponent. And then the last rule that we learned, here we have a power raised to a power, and instead of having two separate exponents, we can have a single exponent by multiplying those exponents. So I have k raised to the second power raised to the sixth power. So my variable k, my base is k, and my exponent is now 12. So let's take a look at the product rule. So again, I would pause the video and then come back and look at my answers. So we have c to the fifth times c to the third. We can write that as a single c by adding the exponents. M squared times m to the negative fourth, I can write that as a single m, and 2 plus negative 4 is negative 2. Then we need to make that into a fraction so that our exponent is now positive. We have two z bases. We can write it as one base, and we add negative 3 and negative 1. We get negative 4. Again, we need to turn this into a fraction and make it a positive 4. On the last ones, we have some coefficients. So this just means we're multiplying 2 times 3, just like normal. And now I can write my two a's into a single a by adding the exponents. The next one is the same way. We just have 4 times 2. 4 times 2 is 8. Then we're going to put the two b bases together. Remember, there's an understood 1 here. So negative 1 plus 1 is 0. So we have 8 times 1, because anything to the 0 is 1, and 8 times 1 is simply 8. On our last example, we have negative 4 times 2, that's just negative 8. We have two k's, so let's write it as a single k, and we add the exponents, and we get negative 3. Now look, guys, this negative 3 is only attached to the k. This negative 8 has its own positive exponent of 1. So the negative 8 stays in the numerator, and the k moves to the denominator, making it a positive 3. Okay, now let's practice the quotient rule. So here we have x to the 7th divided by x to the 3rd. So instead of having two x bases, we can have a single one by applying the quotient rule, which says subtract your exponents, the top minus the bottom. So I went from two bases of x to a single base, and that's what we're trying to do, to simplify. On this one, we have two k's. We have the division indicating quotient, so we subtract our exponents, negative 4 minus 2, keep, change, we get negative 6. So I went from 2k's to 1k. And then we have to make it into a fraction so our exponent is positive. On these two, we're going to have some coefficients. So this is 12 divided by 3, which is 4. My base is a, so I just write the a down. And we have 3 minus 5, keep, change, gives us -2. Now this -2 is only attached to the a. The 4 has its own +1 exponent, so it remains in the numerator, and we bring a to the -2 to the denominator, making it a +2. On our last example, we have 18 over 24. So this is a fraction that we're going to simplify like you did in 5th and 6th grade. So we ask ourselves, what can divide into 18 and 24? What's the largest number? And I see that 6 can divide into each of these. So 6 into 18 is 3, and 6 divided into 24 is 4. So I just write 3/4, and then I just write my W. Okay, we're going to make these two W's into a single W factor. So we're going to be careful because we have 5 minus -3. 5 minus -3. Keep, change, gives us 8. Since our 8 is positive, it remains with the numerator 3, so 3W to the 8th divided by 4. And then we have a power raised to a power. So we have x to the power of 0 raised to the power of 2. So we write our base down, we multiply, 0 times 2 is 0, and anything raised to the power of 0 is 1. Now this next one, guys, we have to be really careful because this 2 has its own exponent of 1. So this outside power is multiplied by every exponent inside the parentheses. So we have 2 and an m. So I just write my base down. 3 times 1 is 3. 3 times 2 is 6. And then if we evaluate 2 to the third, 2 times 2 times 2 is 8. And then we have m to the 6. In our third example, we have a factor of k, and we have a factor of n. So this 4 is going to be multiplied by each of these exponents. So I can go ahead and write my base down. I don't need the parentheses. There's no negatives here, and I'm about to distribute. 4 times 3 is 12, and 4 times 2 is 8. And everything's positive, all my exponents. On this fourth example, we have d to the -2 and e to the +1. So again, I encourage you to write in that understood 1. So we have a d and an e. 3 times -2 is -6, and 3 times 1 is 3. So the d to the -6 needs to come to the denominator to make it positive. The e to the third is positive, so it remains, and then we need to put a 1 in the numerator. Our fifth example, we have 2 raised to the 1 times x to the -2, y to the third, all raised to the power of 4. So I'm just going to write out my base, 2xy, and then distribute this 4 to every exponent, exponent to exponent, power to power. So we get 4 times 1 is 4, x times -2 is -8, and 3 times 4 is 12. So there's two things we need to do. We need to evaluate 2 to the 4th, and we need to move x to the -8 to the denominator. So 2 to the 4th, 2 times 2 times 2 times 2 is 16, y to the 12th, and let's move x to the -8 to the denominator, making it positive. And our last example, we have 1, 2, 3 factors. So I have a 3, an A, and a B. We're going to distribute this 3 to every exponent. So we get 3 to the -3, A to the 12th, and B to the -6. So we need to move 3 to the -3 to the denominator because as a negative exponent, and then we can go ahead and evaluate 3 to the third, that's 27, 3 times 3 times 3. A to the 12th remains in the numerator, and this b raised to the negative 6 needs to be moved to the numerator to make it a positive exponent. So I hope this helps you for your quiz.